Hello everyone, this is Pooja. I am from the Solver team and my teammates are Sirisha and Ratna. The topic we worked on is to solve the Rubik's Cube using the reinforcement learning. The contents that we are going to discuss in this are brief introduction about the Rubik's Cube, the approach we used to solve the cube, and the algorithm, the implementation of our project, the results we have achieved, and the deliverables of our project. Here is the Rubik's Cube of dimension 3 by 3 by 3. So to explain the cube, it has 12 edges, 8 corners and 6 centers. It has 6 faces of each having 9 blocks. It can be shuffled and the goal is to solve or arrange the cube into the state that each face is of the same color. The faces are represented as front, back, top, bottom, left and right. And the colors associated with the blocks are red, green, blue, white, yellow and orange. Our goal in the project is to solve the cube of dimension 3 by 3 by 3 using agent trained with the reinforcement learning algorithm without using the interference of the humans. We have also tried our best to do this is an optimal way using a simple learning algorithm and in the less span of time without any large complexity involved. So in order to implement the project, we have used one of the most common and simple model-free reinforcement learning algorithm called feature-based Q-learning. To check the quality of the cube solved in each stage, we have used the utilization of pattern database. The epsilon greedy policy is being used in the Q-learning implementation to choose the best action. It chooses the best action based on the Q values of each state, and the action with the maximum reward is chosen as the best action. The learning rate, number of episodes, epsilon, discount factor is given to the agent to perform the action and to select the next action. To select the next state, it calculates the Q value for each state and reward is calculated for each state and the best state with maximum reward is chosen as the next state.
Hello everyone, this is Ratna. I'm going to continue with that remaining part. So here I'm going to explaining about this how this Q learning algorithm is worked. So basically we use this feature-based Q learning algorithm. So here we will initialize that Q values for each state and for each particular state for we are initializing that Q value and it's run on a given number of episodes. It's follow the epsilon greedy policy in which the algorithm is given with the epsilon value, discount rate, learning rate, reward using this policy and the maximum reward is calculated for each state is based on the given values. So the new Q value for each state of action is calculated using this epsilon greedy policy only. Then each episode, the state is checked if it is reached to that goal state or not. If it will reach to that goal state, I mean like if it is yes, the reward is associated with the state. And if it is not, I mean it's not reached to that goal state, the process is still repeat until the agent reach to that goal state. So in the coming slide, we can see how it will choose that Q value, how it will work. We can see in the coming slide. So here, this is the formula used for the for updating that Q value for a specific state and action. So the current Q value is considered for calculating the new value. The discount is applied to the maximum reward of the state. So the implementation part is here. In this slide, we can see. I mean, I'm just going to explain it. There is no diagrams here. So the cube which is shuffled is given the input at the initial stage. Then all the states are assigned with the random Q value for each state. Then using this epsilon greedy policy, the new Q value are calculated and using the disc di discounted reward. At each state, Q values are calculated. I mean, and each and every state that Q values are not calculated, there is no scope to skip that calculation of that Q value. And the best Q value is based on the maximum rewards and the next base action chosen until the goal state is reached. In the coming slide, we can see the graph. So here we can see the flow graph. Here the state of the cube is given by the observation. So the Q function updating that agent is used to calculate the Q values. The reward or penalty is calculated, and then best possible actions that are defined here. So the best action is selected, and the same process is continued till we reach the goal state. So this is the sample output we can see here. So here we can see how many rotations it's have done. So here we can see everything. This is the sample example how it is working. This is the shuffled initial cube. By performing the some actions, the pattern is registered initially. Here we are not giving any input. We are asking We are asking in the agent to shuffle, so we are not going to give. It will shuffle by itself. So the random q values are generated like this. Here we can see the both the slides. So these are, in the coming slide we can see these are the pre-staged outputs. Here we can see in the top bottom how the cube is look like. If we see in the top, it's red red red, orange red red, orange orange orange, like this. So this is not the final state. It is just pre-stage of the solving cube. See here, this is the actual solved cube. We can see the output here. In the front, we everything is white. In the back, everything yellow, left blue. We achieve that solved cube in the final. Thank you.
Hello everyone, this is Sirisha. I am here to give the brief demo of the working of the project. Here we have four different Python files. The agent Python file contains the algorithm, the agent itself, and the Q-learning algorithm and epsilon greedy policy on how it works to solve the Rubik's cube. And puzzle file contains all the methods to take the next action, to calculate the reward, to calculate the Q values of the next state, etc. And others and test files are just to test the scalability of the working of the model. So in the agent class, we have multiple variables like Q values, the cube itself, visited states, number of revisited states, and the start state is being taken as either the cube can be given as an array of arrays, each array representing a side, and in which each array is represented as a row, or else if the cube initial state is not given, the goal state is taken, which is the solved cube, and shuffled the number of times which are given by the user. So here given n equals to 20, so if we're not giving any input, it takes the goal state and shuffles n 20 times and makes that as the initial cube, which is a not solved state. So that is the start state, and these are just the actions. This is the variable just to store the actions performed. And the moves, there are 6 different moves: front, back, left, right, top, and bottom. So the initial cube is registered um, in a pattern database, and then by using q-learning algorithm, it solves the cube. So for this, we have given some of the variables like the number of episodes the agent should use to solve the cube, and the discount rate, which is the reduced reward for the state which agent selects, and epsilon is the small value on which the epsilon grid policy works, and the learning rate is the just a value on how the agent learns the model. So the current state is defined, and for each episode, it just calculates the reward and the Q values, and whenever an next action is taken, it just takes the action which has the maximum reward and the Q value. So it repeats for all the number of episodes, and the agent tries to solve the Q within this number of episodes and this number of iterations. So for this, it generates a random q values initially for the initial q, and then for each random value, it generates a hash function and then calculates the q values for the next state. So if the it they again, there are two different things whether to follow the policy or not. For this, will be generating a random value between 0 and 1. If the generated value is greater than epsilon, which is a very minimal value used by the policy, then it follows the policy and generates the Q value based on this formula. It considers the current Q value and then calculates the reward and the discount associated with the state, and it compares it with the maximum reward, and it removes the current Q value from it. That will be the new updated Q value, and it calculates the maximum reward associated with it. So if what if the random value generated is less than epsilon, then it takes the random action without following the policy, and it continues till the goal state is reached, and it stops only after the goal state is reached. So this play method, uh, it just does nothing but it just gives out the actions to the qlearn. Then qlearn will return the number of actions and each action's q values and the rewards associated. So play method will select the best action from the provided list, and it just follows the same procedure again. And for each current state, it checks if that is the goal state or not. If that is the goal state, then the agent succeeded in reaching the goal state, that is solving the cube, and it stopped the play. Then just prints the number of q values with zero value, with non-zero value, with number of visited states and revisited state, just give us an analysis on how it worked. So for this, here is the reward method which calculates the reward for that. So if the next state is goal state, then the reward would be 100. What if it is not? Then there will be a penalty of 0.1. And it just calculates the number of solved sites. Like after a action is performed, then it checks how many sites are solved correctly, or for each side how many pieces are solved correctly. So based on that, how many are less number of solved sites, like which are not solved, that will be reduced from the reward. So that will be the final reward for the particular state. So it just returns the reward. So and the maximum reward is calculated, and based on this it just appends to a new state, and it just compares with the other actions, and what if whatever is the maximum reward, it just calculates that as the next state. Let's go to the puzzle file. Here this is the solve state, which is the goal state that we have given that to consider as the goal state. Or else there is also a method called is goal state, which just compares if all the sides are of the same color or all the rows are of the same color, which says that if it's not a goal state or if it is a goal state. There are different actions that can be performed through this cube. We can rotate the cube, we can swap the first row and last row, we can flip it, whatever. It depends on what actions we perform and what agent selects. And these are the different actions that can that agent can perform, and we can uh, guide agent to take this specific action. And it checks if it is a goal state or not. It moves, and these are the different moves that it can perform. I'll just start this to keep it running, and we can continue our discussion. So if you can see here, it's shuffled a few number of times to make the goal state, that solved cube, as unshuffled, and that has been given as an input state. So now if you can see here, it's been shuffled, and now this is being given as an input that's been registered right now. And let it continue. The Q values have been generated right now for that, for the each state. So this is about the agent class. And if we come to the others file, we just have created it to check if that works for the some random state, and if that's reaching the near goal or not. And the test file just is given to check and compare how it works using the unit test, and the number of the rotations, and how it worked with the 90 degrees rotation, as we worked only on 180 degrees rotation, and to check the equality of the unit test case with the working of the algorithm. So that's all about it. So let's wait for it to be completed. So if you can see here, the agent stopped playing after it reaching the goal state, and it's been aligned properly. Each side contains the same color, and these are the pre-states before solving, and the Q values have been generated for each number of episodes, and that's how it worked. Thanks for your time.
These are the evaluation strategies we have used for our project. The best action is chosen based on the maximum reward of the state. Based on the number of shuffles, we have implemented the maximum of 20 shuffle states. It performed well and reached goal state. The agent at most took 40 seconds of time to solve the cube and to reach the goal state. The algorithm used is a simple model free learning algorithm and just works fine with the Q values. To conclude our project, our agent is trained using the feature-based queue learning, the algorithm works on the queue values. The next action is chosen based on the maximum reward and the queue values by applying the reward or penalty to the given actions. The model performed well within the span of time and the agent stops playing only after the goal state is reached. The deliverables of our project are source code and the video for project explanation, the presentation report and the technical documentation has been prepared to give the complete overview of our project and the code. Thanks for your time.